enterprise telecom network in GNS3 using FortiGate firewall. So this project includes the SD-WAN and IPsec VPN between the two sites. At the end of this particular project, you will be in position to configure the IPsec VPN site to site, and also you'll have mastered how to configure the SD-WAN and troubleshooting SD-WAN related issues. So the two sites are connected through the VPN tunnel, and the internet service is being provided by dual ISP. So at the head office, that is India, it is provided by these two, Hathaway service provider and Exitel service provider. But in Kenya, it is also provided by Seacom and Safaricom, providing balance between the two. So in India, I'm going to configure the SD-WAN failover so that when this particular link fails, this one takes over, to ensure that there is a redundancy in terms of internet connection. Because this is a telecom network, it is a complex network that other small providers and other customers or users rely on. So it should be up always. So when it comes to Kenya, Kenya is a branch. I'm going to configure SD-WAN load balancing so that when traffic is too much or traffic is high on this particular Seacom fiber link, it will be propagated further to be carried on the Safaricom link. So India being the head office, it has the data center here. You see in the data center, I have the domain controller, Microsoft domain controller, that is, they are using Windows Active Directory. Then they have also Ubuntu server. So the data center is just a collection of servers that are hosting multiple sites. When in Kenya, you can see that there is a server room, meaning this is just a minimum site for such. So there is no much in Kenya. That's why there is just a mere server room, but majority of the services are accessed over the internet through VPN. So the first steps here, I'm going to configure the interfaces, the LAN interface, the ISP interfaces, and the management interfaces, both starting at India, the head office, then proceeding to Kenya. But before we move to that, there is this particular switch. There is this particular switch here. So this switch here, it is acting as a gateway as management is concerned. It is giving me the ability to access the two firewalls in the web via this particular cloud here. So this cloud is connected to the GNS3 server. Let me show you the server itself. This is the server. This is the GNS3 server. So all these firewalls will get the IP address automatically from the server. So to make sure that my space is clean, I will hide the interfaces and remove the switch and the cloud from the space. So port 4 is connected to the management, that's the management port. Then port 1 on every firewall is connected to the first internet service provider. Then port 3 is connected to the second internet service provider. So I'll just right click, then style, then we just make it visible, apply. Also we do this. So once we do that, I'll just select this one, then I remove it from the workspace. So that is it. Let me start by the head office. This is the firewall for the head office. So first you create the admin account. Once admin account is created, you configure the host name for identity. Then we configure the interfaces. Now the second step on the interfaces, I will start with the port 1. Port 1, this is the port facing the first internet service provider, that is Exeter, this one, ISP1. So then set allow access ping HTTP, then set alias Extel ISP1. Then next, edit. Remember, all the internet service provider ports are going to get IP address automatically. Set mode static, this is the LAN. Set IP 172.30.20.1/24. We allow the ping service on the set role, that is the LAN. Set alias India LAN. Next, edit port 3. We set mode, this is connected to Hathaway DHCP. Set alias Hathaway ISP2. Then set allow access ping HTTP. So once we are done, then we go to port 4, that's the management. Port 4, set mode DHCP, set allow access HTTP, telnet ping FGM, set alias MGT, that is the management. So at this stage, I have successfully configured the host name, configured the LAN interface, configured the ISP interfaces. So we will verify the IP address by entering this command, diagnose IP address list. You will notice that port 1, that is the ISP number 1, it has received this IP address. Then this is the LAN IP. Then this is the ISP for the second, the IP address for the second ISP. Then this one is the management IP. Hope it's clear. So I'll use that to access the Indian firewall. Admin. So once we access that one, I'm just evaluating the license at this stage. Once the license is evaluated, you extend the idle time. This one to prevent regular logouts. So once you do that, you are done. You move to the next firewall. You see, remember, .135, it is for this ISP1, then .137 is for the second ISP. So I have successfully configured the interfaces on this head office. Now I'm moving to the Kenyan branch. So on the Kenyan branch, it is provided by two ISPs, local ISPs. Remember, an ISP can also be further served by the ISP. So now, this one being an international ISP serving in a country, it is being provided by the ISPs hosted in that country. So CCOM is providing, this is a fiber link, then this is a wireless link that is provided through microwave dishes. So at this stage, port 2 is a LAN port, port 1 is the first ISP, port 3 is the second ISP. Port 4 is the management port. I had shown this particular case earlier. So I'll access Kenyan firewall. This is it. The first step is to set the administrator account. The function of this administrator account helps you to access majority of the services on the firewall. The second step is to set the host name. Host name helps the identity, FortiGate. Then once we set that, we configure system interfaces. Edit port 1. Remember the ISP ports are receiving IP address automatically. Set alias. Port 1 is Safaricom. Next, edit port 2. This is a LAN port. Before you set IP, you have to specify the mode through which the port is going to function. 172.30.21.1/24. Set role LAN. Set allow access ping HTTP. Then set alias Kenyan LAN. Then after here, next, edit port 3. This is the second ISP. Allow access ping HTTP. So that's okay. Set role, it's a 1 port. Set alias CCOM fiber. CCOM fiber link. So once we are done that, we can verify diagonalize IP address list. At this stage, port 1 Safaricom has issued this particular IP to its link. Then this is the LAN port. When we repeat, we will get the ISP for the address for the second ISP, but the management is still. So while waiting for the management, configure system interface, edit port 4, set mode DHCP, set allow HTTP, set alias MGT. So that is the management. I had not configured the management. Diagonalize IP address list. You see, the moment I have done that, you realize that the management is given this. This is the IP for the management. And we can reach the management. You see, I'm able to ping the management IP, meaning I can access the management IP. I can access the firewall through the management IP. So the same, I will log in with the administrator account that I had initially created. Then what I will do, I will evaluate the license. Once the license is evaluated, I will extend the idle time. This is for simulation, but in production, don't extend the idle time, because that one will impact. In case a threat actor happens to access the system, will stay logged in, and he can cause chaos in the system, bringing production down. So I'm just doing it so that it cannot lock me out as I simulate this. So successfully at this stage, I have managed to configure the interfaces at the head office, which is in India, and also the branch that is based in Kenya. So the next thing, I'm going to configure the SD-WAN. the SD-WAN. So on the SD-WAN, I will start with the SD-WAN in India, that is the head office. But before I proceed on that, I'll enable the DHCP capability on the LAN interface so that computers or nodes connected to the LAN, let it get from 20. So at that stage, it's okay. So once this is done, I'm going to create the SD-WAN. To create the SD-WAN, first of all, SD-WAN, this is where we use software-defined related concepts to determine the performance or to optimize the ISP link usage. So in this scenario, I'm going to create the failover so that when this ISP fails, when this one fails, this one takes over. And I'm going to demonstrate that. So, first step, you create the zone. The zone is just like a container that houses the links. So, I'll create the zone. The zone, this is India SD-WAN. I'll just create the zone without adding the members. By default, when you create the zone is always down. But the moment you add a member within the zone automatically comes up. That's what you should know. So, the next thing is to create the member. You specify the interface that connects that member. So I have two interfaces here. There is port 1, this is Excel, then port 2, that is the port 3, that is the Hathaway. So I want my priority or primary link to be the Excel ISP. So this one will be my secondary. So the first step, I'll pick this one, then I'll select the zone. At that, let it remain dynamic because it is getting the gateway is dynamic. In terms of cost and priority, I'm not going to do that. That one, I'll effect it in the Kenyan branch where I'm going to implement the SD-WAN load balancing. Load balancing is effected through cost and priorities. So I leave it default. The moment I do that, you realize that the zone is up already because there is a child within that zone and it has already received the automatic gateway. So then I'll create the second member. You just choose the link, then you choose the zone. So this member, it means that this member is going to be bundled within this particular zone. And remember, FortiGate Firewall gives you a default zone. You can edit this default zone or you can create yours. Or in an enterprise network, you may be having multiple zones. Maybe the network is segmented in different zones, so you can create that way. So once this is done, click OK. The moment you do that, you realize something. The green part, this is port 1. Port 1, I told you that it is my primary link. You see, it is taking the bigger share when it comes to bandwidth. When it comes to volume, still it is taking the bigger share. When it comes to session, it's taking the bigger share. Though at this moment, this is the traffic that I had initially initiated via CLI, you see. So that is it. So this is the primary link, then Hathaway is the secondary link. So the next step, I'm going to create the the performance service level agreement. Then after that, I'm going to create the SD-WAN rule that will affect the performance service level agreement. So I'll create on the aspect of packet loss. So this is ping Google, ping Google. Then let's use ping. We specify the server here. Then on these participants, you specify the members, but in line with the priority. So I had mentioned that this is my primary link, then this is my secondary link. You see the primary link is always at the top. Then you enable this. Latency, let's give it 1. One, 2, then restoration 1, that is 1. Or we just give it 1. So once we do that, we click OK. You see this is the service level agreement that has been created. You realize the graph is drawn in terms of packet loss. Now there is no packet that is passed, the packets that are passing, but you realize packets had already passed through port 3. So in terms of jitter, you see, that's what you will see. But before this rule is effected, we have to create, before that SLA, service level agreement, to be effected, we have to create a rule. So this is access internet. The source is all. Then there is no group. Destination is all. Then on the destination, we are going to choose any, meaning TCP and UDP will be used. Then on the strategy that we are going to use, it is manual. I'm going to manually select. So on the interfaces, I'll prioritize Excel, then select the next. So the primary is the first one, then the secondary is there. Then on the zone preference, I prefer this particular zone. Then I'll click OK. I'll click OK. So once that is created, we come on the static route to create a static route and a firewall policy to allow traffic to pass through the SD-WAN. But let me tell you this, when traffic comes from either the data center or this particular LAN to the internet, it will neither use Hathaway or ISP1 interface. It will use a virtual interface called SD-WAN interface. So the virtual interface is bundling the two ISPs. So the first I'll just choose the zone. It means any traffic on the internet or any host on the internet through this particular interface. You click OK. Then the next is to create the SD-WAN rule, LAN to internet. So the incoming, it will be the LAN port. Then outgoing, it will use now you are not seeing either port 1 or port 3. You see, because it is bundled here, so we choose the zone. Then the source. The source is all. Then the service, we are going to allow all the service. The destination is also all. Then at this stage, we'll just all sessions then generate traffic, or we can just leave it security events. I'll tell you the reason why. So at this stage, you see the rule is synchronizing. The rule is synchronizing. So it is checking whether traffic is passing or it's not passing. So at this stage, what I will do, I'll allow one of the hosts here. That is, let me give it a name. Engineer 1. So Engineer 1, based in India, is trying to access the internet. Let's see what will happen. The first of all is to check he or she must receive IP address automatically. You see, the computer has successfully received the IP address automatically through the DORA process. You see, this is the IP. There is a conflict to do this particular. There is a conflict to do the interface. Let me just change something here. So this is the domain controller. You can see the domain, it is NetLabs Hub, then administrator here. So you see it has detected the internet. So you see NetLabs Hub is connected. So this is the main data center for this particular telecom provider. You see. So when we try, let's try this one. DHCP. You see, it has received this IP. DHCP. So these are the issues that you will be facing if you don't organize the interfaces well. You see, this is the IP that has been received. Then when it comes here, it has detected the LAN IP, but that is the case. So let me initiate traffic from this firewall. Execute ping ping the internet. You see, it's pinging. So we have successfully, we can access the internet. So the moment we do that, let's check the SD-WAN, our SD-WAN, the way it is behaving. You see now, traffic is passing. because the two links are up, that's why you see, but packets are being prioritized to pass through the primary link. Now let me put the primary link down and try to access the same. So I'll just suspend the link. So once the link is suspended, we just repeat the same. You see, still traffic is passing through. So this is how SD-WAN failover works. You have two links. One is primary, another one is secondary, so that the preferred link, when it is down, the alternative link picks up and it continues operations. So that's how SD-WAN is deployed in this particular network. When I refresh, you'll notice something, that traffic has now opted to use port 3. Port 3 is the Hathaway link. You see, this one is down now. Check the size of traffic that passed through the first link, then the second link. You see, now the second link has taken over. The graph here will show you that the better proportion of the bandwidth is passing through the Hathaway link. So that is SD-WAN failover. So the next thing, I'm going to create the same SD-WAN load balancing on this side before I create VPN. VPN will be the last aspect, because I have done. So this is Kenya, this is India. The first thing, I just create a SD-WAN a bit faster, but now I realize what I will do when it comes to load balancing. The first step, I'll create the zone. You create the zone. This is Kenya, SD-WAN. Then, okay. Once the zone is created, you create a member. Specify, so I want the Safaricom link to be my primary. Then I'll select the zone. Then the same will remain. But on the primary link, I'm going to prioritize. The lower the priority, the higher the preference. So I'm going to give it 10. Then the cost, I'm going to give it 20. You see, this is the cost, this is the gateway. The next, I'm going to create a member, that is CCOM. I bundle it in this zone. So I'm going to increase the priority to 20, then this one is 80. So you see, as I speak right now, port 1, which is Safaricom, is taking the 80% of the bandwidth, while the other one is taking the 20% of the bandwidth. You see, this is what I'm trying to load balancing. So when traffic is so high in the network, it will be preferred to go through the link that has been given the precedence or the preference. But when the traffic is so low, it goes to the link that is not so much overwhelmed. In terms of bandwidth, this one is 100 Mbps, then CCOM is providing 100 Mbps. Safaricom is 200 Mbps, then CCOM is 100 Mbps. So at this stage, I'll create on the load balancing. Remember, on the link SD-WAN failover, I used the packet loss as a service level agreement strategy, but now I'm going to create using Cheetah. So ping Google. The server, I'm just going to give it 1. Then the participants, I'm going to give Safaricom the preference. Then the second, I'm going to give Seco. Then I'll enable the service level target. So latency is going to be 30. Then jitter is going to be 0.5. Then packet loss is 0.5 again. This is going to be default, or we just give it 1. Failure before inactive, 1. So we click OK. When that is created, now we create the policy here. We create the policy. So the first thing, access internet. The source is all. Then destination is all. Protocol is any. So on the aspect of strategy here, I'm going to move with the maximize bandwidth. You see traffic is load balanced among the interfaces that meets the service level agreement targets. So then on this, the preference is this. In that order, the zone is this. Then required SLA target, I'll choose this target. This is the rule that I created, remember. So the links will behave according to how the service level agreement is created. You see the packet loss, the latency, jitter as specified. So that is it. Enabled, ensure the rule is enabled, then OK. You'll notice something. You see, traffic is load balanced here. So 50 is passing through the first link. Then this one is also taking the another share. Now see, you see, all the paths are full. But in terms of cost, you see, so let me just, there is something that I have not created here. The first now static route. So the static route is all. It means any on the internet, access any on the internet. And then when it comes to the interface, it's going to pass through the zone. That's okay. Then the next is the rule. On the rule, access internet. The source is port 2. That is the LAN port. Outgoing is that particular zone. Then this is everything. I'm going to allow everything on the source, then everything on the destination, every service. Then ensure NAT is enabled. There is no security profile that is available at the moment. Then choose that. Generate logs, then OK. So the moment we do this, execute, ping, you see, I'm accessing the internet by the power of this particular SD-WAN rule that I just created. So I want you to verify together. Now you see, after now traffic, remember initially when the zone was created, then members were added, traffic was load balanced 50-50, like it was a half. The yellow part was 15, then the green part was 50. It means in terms of bandwidth, it was sharing the proportion. Now you see the volume. I preferred right now, traffic is preferred to pass through the Safaricom link because it has more bandwidth, you see. You can see here. But in terms of bandwidth, Safaricom has more bandwidth. Then in terms of volume, Safaricom takes it all. Then in terms of session, you see. So I have conditioned this particular SD-WAN in that when the traffic is so high in a network, in that case, I was accessing the internet via CLI. You can see here. You see, traffic is passing. So at this stage, traffic is passing through the Safaricom link. That is the prioritized primary link. You see. But now let me shut down this particular prioritized primary link. This one, I'm shutting down this particular link. So once this is shut, now traffic is going to be load balanced to the other as per the service level agreement created. This is a technical situation that you should understand. Don't cram, just understand. Or if you've got any issue, please leave a comment on the channel. I'll help you. So now Safaricom link is down. You see, priority has shifted to the CCOM fiber link. And remember, there is no traffic that is passing, but it has already changed the precedence. So let me now initiate traffic, execute, ping. You see, I can access the internet. So at this point, traffic now has no choice but to pass through the link that is live. You see, Safaricom is down, so the entire bandwidth is passing through the CCOM fiber link. Then in terms of volume, Safaricom takes it all. Then in terms of sessions, the active sessions are passing through that. So that's how traffic is balanced. You see, there is no traffic that has just passed through the Safaricom link. So that's about the SD-WAN load balancing and SD-WAN failover on this side. So the next thing now, I'm going to show you how to configure the IPsec VPN between, this is like a site-to-site VPN simulated using FortiGate firewall. So the main firewall is based in India. Then the secondary firewall is based in Kenya, Nairobi, which is serving a branch in that site. So when traffic comes from this particular LAN or the data center, it will not pass through these internet service providers. This one and Safaricom will not know which type of traffic is passing. When it reaches to this firewall, the firewall is now mandated through the power of IPsec VPN. An automatic tunnel will be created between the site to allow the traffic. So it will work in what we call three-way handshake. It will negotiate. A session is opened, traffic is passed. Then once traffic finishes passing, then the session will close. That is through the TCP. TCP is like a three-way handshake. So it will work in that mode. The session is only opened when traffic is passing, and once traffic has passed, the session is terminated or it is closed. So that is it. I will start by creating the India. I'll start creating the IPsec VPN on the Indian office. So you come on the VPN, then IPsec tunnel, you create the tunnel. Remember, I'm going to choose this site to site. This one, you are aware of this, and this one I had already done. So this is India VPN. Site to site is my template. You see, I have 2 FortiGate firewalls. In between, I have 2 ISPs providing this side and this side. So the local remote IP. So in this scenario here, I'm not going to use this. CCOM and Hathaway are just there to offset the SD-WAN capability. But when it comes to VPN, VPN will work through these links now. The links that are connecting the 2 firewalls. That is Excel and Safaricom. So on this, I'll choose the remote IPs .192.122, 192.168.122.185. That is the remote. Then the local. So the remote is this one. .185. So the steps, once this is the IP on the other side. So I'm in India right now. So this is the IP for Kenyan ISP. So let me just show you. This is what I may need, this IP here. You see? Then you authenticate via using pre-shared key. You can also use a signature, but in my case, I'm using pre-shared key. Next, you specify the local interface. So the local subnet, there is no big deal to type here. You just select the local interface. This is the interface that is connected to your local area network. So that is port 2. The moment you select the right interface, it will populate the subnet. Then the remote, you will have to type 172.30.21.0/24. So this is the remote subnet. Then next. Once you create next, that's how we've just created the tunnels at the head office in India. And remember, this tunnel has 2 phases. There is phase 1, then phase 2. You realize that phase 2 is already up, but phase 1 is down. So when you use this kind of VPN, there is an automatic static route and backhaul route that are automatically created, and also policies to route traffic to and fro are also created automatically. You see, you can see show tunnels. You see, so you see the tunnel is trying to negotiate, but it is not getting its peer. That's why it's down. But the moment I finish configuring the tunnel on the other side, you will realize that it will start by either phase 2 or phase 1 to be up. Then it will force the other two also to be up. So in this regard, let me I have finished creating here. Now it is this site. Site-to-site VPN is one of the common security implementation in enterprise real network environments that is used to shield off the threat actors from accessing the organization's data, so that users, while browsing the internet, their traffic is not going direct to the internet. They are just using the internet to create an automatic tunnel through which traffic is passing through to their intended destination. So I'll choose so on this I'll move a bit faster. This is Kenya VPN. then site to site. Remember, when it comes to VPN, there is no NAT between the site. On this, I'll choose the remote IP 122.135. Then this remote IP is passing through it's not CCOM fiber. Let's just check something here. So it is not passing through this, it is passing through the Safaricom. That's what you should understand. Then you enter the pre-shared key that you had also created on the remote side. Then local side, you just pick the LAN interface. Then the remote, you will type 172.30.20.0. So you see how this tunnel is created. It is created using the internet IP addresses that are provided and the local connected interfaces. So you just reverse. For example, at this point, the local was the IP that is there, and then the remote is the IP on the other side. Then when you come on this side, you use the other side as that one. Then next, you create. The moment you create, you realize phase 2 is up. It has automatically created the static routes, the to and fro static routes, the to and fro remote firewall policy through this particular VPN tunnel interface. You can see. Remember, on the hit count 0 bytes 0, there is no traffic that is passing. When you come and verify that, so the tunnel is negotiating. Just a minute. This is 135 on India diagonalize IP address list. Port 1 is 135. It's okay. So let's check this side. This is 185. So sometimes you may find that the outgoing IP address for the remote, there is a mismatch. So this is 135 port 1 Xtel, then this is 185 on Safaricom link. So the sites are syncing. So on this, just check something here. You see, the problem is here. The sites are not coming up because, remember, this is traffic. The tunnel must be created between these two sites. These sites, it's okay, it is passing through the Safaricom link, but when it comes to head office, there is a problem whereby the tunnel is going to using the hathway. It should not be the hathway, it should be this particular ISP. So That's where the problem is. You see here, this is where the problem is. It should be through this. The moment I just choose OK and save, now see what will happen. The tunnels are going to be up. So those are the issues when it comes to with the IPsec. You see, there is auto negotiation, automatic auto negotiation. So once that, you see, the tunnels are up. So that's how, you see, I have successfully configured IPsec VPN. So this is how we troubleshoot VPN. In real environment, know the link that is facing the other side. So you see, in this case, I created the tunnel, then the outgoing interface, I chose the port 3, which is wrong. It should be port 1 because this is the port that is facing the other side, the branch. You see, on this side, there is no any other port that is facing that. This is just here for the purpose of the SD-WAN failover. I can repeat the process so that you can see how to troubleshoot it better. Just come here. For example, this is for Kenya in the branch. So I'll just pick CCOM. The moment I pick CCOM, there will be no negotiation. The tunnel shall go down. You see, the tunnel is inactive. When I refresh on the headquarter side, you see, it has returned to the initial position. So to troubleshoot this, know that particular site that is facing your tunnel opponent. So in my case, you must know the outgoing interface. This is the outgoing interface. So it means this ISP and this ISP are coordinating here to provide a platform over which these users can access the other side over the internet, not through it. So over the internet, it means they are going to achieve that through their dedicated path. That is the IPsec VPN tunnel. So let me bring back the interfaces, troubleshoot this error. So you just come on this. On this, you just edit on the network. Then you just give it Safaricom. Once you do that, then refresh, your tunnels will be up automatically. For you to understand this, let me show you the logs. You can see the events. First of all, I can show you the events. On the events, let's start with you see, this is the auto negotiation that I'm talking about. You see that 6 seconds, 17 seconds, success, you see, negotiation error. That is when I change the IP address for the remote site. So that is a VPN on the SD-WAN. You see these are the logs that are generated on that. So let me just go to the VPN, then try to impute traffic into the network. So I'll access this PC, PC4, PC3, it is on the Kenyan branch, IP DHCP. So the problem, this firewall, I have not enabled the DHCP on the firewall. DHCP on this interface. That's why it's not working. It's giving us errors, you see. You see, building a network is an easy thing, but maintaining that network is another hell in the park. So you should be able at least reserve that energy to troubleshoot the network than building. So the moment I do that, or I repeat DHCP-D, it will pass through the DORA process, discover, offer, request, acknowledgement, then finally it will issue the IP address intended. You see, this is the IP address intended. So at this stage, let's ping. You see, first of all, let me at least give it continuous traffic. So I'm able to reach the internet. So in this case, this computer here is accessing the internet. Remember, there is SD-WAN here. So when this link fails, still it will access the internet through this link. When this link fails, it will access the internet through this alternative link. And also, it is not accessing the internet directly. When traffic arrives at this firewall, it is choosing to go through that particular intended site through the tunnel. Okay, you see traffic is passing. Let me check. Piece 3, so piece 4. Piece 4 IP DHCP. Successful. Let's ping 192.168.130. Is it 135? 135. You see, I'm able to reach the other side. You see the other side, this is the IP for this particular part. Remember, this computer is able to reach this. It is reaching here through the VPN, not through these two ISPs that are in the middle. So at this stage, if you want to see that VPN is working, I'll come on this interface, then try to do what we call packet capturing, or capturing packets. You will understand that alongside the packets that will be captured, you will find there is Internet Security Key Association Exchange. It means the packets are done what? Are encrypted. Remember, when traffic is moving from site to site VPN or over site to site VPN, you cannot see the traffic. The traffic is just encrypted. So when it reaches to the intended destination, it is the role of that particular site to decrypt the traffic to see what the message was all about. So remind me on that. So I want you to just to bring to your attention that indeed packets are being captured here. You see this one? It means this host accessed this particular site. Then let me just stop a bit. This one, it is using what? ISMP, Internet Control Management Protocol. This host is accessing the Google public DNS. Then this host is also accessing the Cloudflare, CloudStrike DNS. But you realize these protocols are changing. Here it's ARP. It is trying to negotiate for the IP. Then there is a part. You see here, traffic is passing through the TLS. You see description here. Just a minute. You see, this is DNS. So let me resume traffic. Let me just close it first, then stop. Then capture at this point. So this is how you can capture packets. You will understand the size of the packets that were sent, the protocols that were in coordination. You see, this is for the VPN now, this TLS version 1. So that is about packet capturing. So I have successfully configured the enterprise telecom network. So the next thing, I'm going to simulate a project that will encompass the hub and spoke VPN, then interVLAN routing if possible, to simulate a corporate network between multiple sites. So just to finish, to let you know, this is the data center. I have not talked about the data center here. The data center is controlled by the domain controller. So the domain controller here is managing all the computers from the head office and also on the connected branches. When I just log in, you see it is connected to the internet. NetLabs Hub is the domain that we are using. Though it is something that I will talk about, Active Directory is a session that will be coming later. Let me just show you something. So I have successfully created users. All users are on this domain, you see. The domain is DC1, and this is the domain. Then it is enabled. This is the IP address for that domain. So that then these are the settings for that domain. If you want to see that the domain is working, you can just ping netlabshub.com. You see, it's pinging successfully. It is translating this particular domain name to a tight IP address. This is an IP address that is accessed from assigned from the LAN. So I'm using a MikroTik router here that is issuing this IP address. So I decided to configure this particular Windows Server 2022, the static IP, to simulate the Active Directory. So also Ubuntu server is here as a second server. Ubuntu server is there for this to serve as FTP server, email server, When it comes to this side, this one is serving as a DHCP server and other related service as a database. Also, it's on this particular side. So this is how an enterprise telecom network is configured And in this regard, I have just simulated using the features that I have highlighted here. Software defined, that is SD-WAN, both failover and load balancing with the power of IPsec VPN, encompassing VLANs, because this is a LAN on its own. This is a LAN of its own. It's encompassing DHCP. So I hopefully believe you've learned all these particular features in this particular project. Please feel free to subscribe to NetLabs Hub, leave a comment, watch, like, and share. Let's meet in the next video.